So for this little demo here, we will be looking into fitting curves, right? So fitting curves is pretty much going to be giving an output of a signal that would be represented by two independent variables, right? And in one of my other videos, we would be doing this by observing it with an initial signal, which is a very clean signal, and then with a noisy signal, right? And this is pretty much the same implication here, right? Um, and we'll see that here. Um, but anyways, to create an output that it has a variation of two independent variables, at first we would be creating those two independent variables here, which is what I do. And this one is just pretty much depending on the output of x over 10, right? And then this one is depending on the sine function of the sine function where the input, well, where x over 10 is input into the value of the function of sine, right? Um, and of course, this is done into the iteration of 100, right? So uh, that should be clear as well. And so this RF here, this RF function, we are first declaring two different arrays, which are our two independent variables, and then we output this RV. Um, uh, we output this RV value, which is to be returned for this general function. But all that it's really doing, it is generating an output that inside this sine function, it is multiplying element wise with the uh, initial our initial uh, input value, which is from here, right? And then it is basically multiplying it by a value that we're going to be inputting, which we'll be seeing in a bit, right? Um, but yeah, it's just going to be generating a new signal. That's all we're doing here. We're just generating a new signal that is depending on us, right? Our new variation here, right? Um, and that's all it's really doing. So we would have this output signal of RV, right? And then with this output signal is going to be now declared as YV. All right. So this YV is going to be a value that corresponds to two independent variables, right? So now it's going to be a new interesting signal. And then we create um, a new function here that has a parameter of h0 and h1, right? And now we're just creating a curve fit, right? And we're creating this curve fit signal, uh, being based off of uh, um, our two independent variables, and then our output of our new interesting signal here, and then our two parameters here. All right, and we are just generating a plot. All right, we're really just generating a plot to compare these signals, right? And so, I mean, here they are overlapping, right? Yeah, they're pretty much going to be overlapping here. Well, this figure one is generating this um, this plot here. Um, but we want to observe, right? How the variation of our initial values is gonna vary the curve fitted graph, right? Because these are pretty much our initial guesses and seeing how these are gonna vary the curve fitted graph, right? So um, going along here, we would see that um, that uh, this a different configuration would be very much different, right? With 4 and 5, because this is not our initial intended values here, right? This one's 4, 5. This one's 2, 3. So it's going to be drastically different, right? From our initial signal and our curve fitted signal. So that's why it looks very, very much funky, right? And then moving along here, we would actually notice that they overlap pretty well. And I think it's because, now I'm not all too sure, but I think it's because um, as long as one value probably remains constant and the other value is relatively close to the initialized value, which is 3, right? So it's just gonna come out that it's gonna make a marginal difference, and maybe there is a difference here, right? But it's very you probably have to zoom in very much to actually observe it, and we actually don't really observe it all too well here. But that's what we would notice there. Um, and then here we of course are getting very we're going like far-fetched values, right? We're going very very far into our initialized values here, which are 2 and 3, right? And we're doing 23 and 21, right? And of course, our resulting curve fitted value is, well, it's going to be pretty ugly. So this is not going to be even anywhere close to our initial 2, 3 values there, right? So that's how we can now that I already like showed the 5 different curve fitted values that relate to its initial signal, we can see how these inputted values can create great influence to our with hint function here.